For this proof, we have to prove using math induction that n times n squared plus 5 is divisible by 6 for some integer n which is greater or equal to 0. So to start this, we have to prove a base. So to prove the base, we have to show that it is true for the lowest value, which in this case is 0. So we have to prove that this is true for n equals 0. So we just come over here, and then n times n squared plus 5 is divisible by 6. And then you just substitute in the 0, and 0 is divisible by 6 because 0 over 6 is just 0. All right, so now that we proved that for the base, 0 is divisible by 6, we can move on to the next step of the process. So we have to assume that for k equals n, that k times k squared plus 5 is divisible by 6 for some integer k. So that can be rewritten as k cubed plus 5k is divisible by 6. So once we have that, we have to prove that if it's true for k, it's true for k plus 1. So to do that, we have to substitute in k plus 1 to the k times k squared plus 5. So then you get k plus 1 times k plus 1 squared plus 5 is divisible by 6, which becomes k plus 1 times k squared plus 2k plus 6 is divisible by 6. That all gets FOILed out into k cubed plus 3k squared plus 8k plus 6 is divisible by 6. What's interesting is that you can break down 8k into 5k plus 3k. So that can become k cubed plus 3k squared plus 5k plus 3k plus 6 is divisible by 6. All right, so we know that k cubed plus 5k is divisible by 6 by this right here. So now we just have to show that the remaining, which is 3k squared plus 3k plus 6, is divisible by 6. All right, so we can actually factor out the 3k from over here. So that can become 3 times k squared plus k plus 2 is divisible by 6. And because we know that 3 times 2 is 6, we just have to prove that k squared plus k plus 2 is divisible by 2. Now we have to do math induction again. So we have to do it again for the k squared plus k plus 2. So we must show that it's true for k equals 0, which we can do because we just substitute in the 0, which becomes 2 is divisible by 2, and that works. And then we have to move over here to where we have to assume that j equals k for j squared plus j plus 2 is divisible by 2. So to do this, we also have to prove that j plus 1 is true. So you just substitute in the j plus 1 again, so you get j plus 1 squared plus j plus 1 plus 2 is divisible by 2. And then that becomes j squared plus 2j plus 1 plus j plus 1 plus 2 is divisible by 2. And since we know that from right here that j squared plus j plus 2 is divisible by 2, we just have to show that 2j plus 1 is divisible by 2 now, which just becomes 2 times j plus 1, which is divisible by 2 because the 2 out here.